Assalamu alaikum. Today we'll be going over the specimen paper question 1 specifically, which is data representation for 9618, which everyone else will be appearing in from now, right? So the first thing we'll be going over is this question. So question is from the specimen paper specifically, right? So the first question is, state one difference between a kiwi byte and a kilobyte, right? So the best answer to this is kiwi byte is 1024 bytes, while kilobyte is 1000 bytes, right? So here's the difference between the two. You can also represent this in terms of power, that kiwi byte has a binary prefix, whereas kilobyte has a denary prefix, meaning kiwi byte raises up to in powers of 2, whereas kilobyte raises up into powers of 10. So that's the difference between the two, right? And give the number of bytes in a MIBI byte. So 1024 multiplied by 1024, and if you want to like calculate the final answer to this, 1048,576, you will have to do this by hand, because first of all, calculators are not allowed in computer science examinations, right? Now we'll be going over this binary addition. So for binary addition, we should be aware 0 1 always raises out to be 1, 1 1 raises out to be a 0. This is carried forward. 1 1 raises out to be a 0, 1 1 carried out to be a 0. Triple 1 comes out to be 1, 1 1 will be a 0, 1 1 will be a 0, and then here's a triple 1, right? So this specific number is important to us, because then they're saying describe the error that occurred when you added the binary numbers in part C1. So you have to write overflow occurred, and you need to explain why overflow occurred. Overflow occurred because the answer cannot be represented in 8 bits, because here we were using 8-bit registers to do this addition, right? So when you're adding the two, you're coming out to be a 9th bit, right? So that is important here. Complete the binary subtraction. So for binary subtraction, you can do it. You can change this number to 2's complement. You can change this number to 2's complement and add the number, right? So to do this, how do we change the number to into 2's complement? First of all, we flip the bits and then we add 1 to it. 1 1 will raise out to be 1, 0 1, and 1 1 1 0 0 1 1. Now we're gonna add the 2. 0 triple 1 double 0 1 1. I'm gonna add these two. 1 1 1 0 triple 1 1 1 1 0 1 carried here, 1 1 1 0, right? So here is my final answer, right? So this is using 2's complement addition, right? So it's the same thing, it's pretty much the same thing as this, but to replace the minus sign, right? To replace the minus sign, I'm changing this into a 2's complement form, where the most significant bit would raise the power to be minus, right? And this final answer would then be 0 0 1 1 0 1 0 1. So this is your final answer. So this question was fairly simple. All you had to do was differentiate between kiwi byte and kilobytes, and give the number of bytes in a MIBI byte, then do binary addition, then explain an error that was caused due to that binary addition, and then you had to do complete the binary subtraction. And for binary subtraction, rather than subtracting the two numbers, we actually changed the second number into 2's complement and then added it. So this was a very recent specimen paper, and these are the kind of questions you can expect to come in your paper.